Hey guys, I'm back here again in here and I keep working on this. So I did a few just to nothing soldered in. I just placed these, got location of some of the pieces here. FET goes here, diodes, transistor. Just to try to speed up the video a little bit. Stuff gets pretty repetitive. The only thing I think I don't have on here is my Hall effects. Doing this part here is kind of tedious, and I might just show a part of it when I do that stage. That'll be one of the last stages I do. But yeah, everything else would be good to go here. Sorry about the inverter. That thing's annoying, I know. Turns on once in a while, the fan on it, but needed it for power. And here anyway, that's what I use. Got some non-royalty music on in the background, so hopefully that'll help drown it away a little bit. This could take a while here. I'll be try to do another hour here anyway. Pretty tired again, but keep at it. Get it done actually. I don't think I'll get it done today though. Too much other stuff going on. Busy. So these are done. We tested those already. I'm gonna take these parts out so I don't lose them. Flopping these around quite a bit. I should go over too a little bit here before I start is what I've already done on here. So got this part of the circuit here done right here. Right there. We started off with the 555, and the IC holders are for this right here on the bottom. These two pieces right here. And then there's the capots, the regulators, this right here. The cap is right there. Right there. That's about it for that. You have all this stuff here to put in. This is one half. And then the other half is kind of mirrored to what this is. Except, the output is reversed. They go to the same jack to the same output here. This is it right here, but you get one side of the output is positive, negative, and the other side is positive, negative, but they oscillate. So that's what's happening here, and the flyback circuit is right here, and it's separate now from one another till I get the PNPs to combine one single battery on the input. That's how it has to be with two separate batteries. Hopefully I get some time next few weeks to build that circuit. It's easy to build with commutators. I used to use it in the past with commutators. But when you're trying to combine these two circuits together electrically with electronics, it's different because you need common grounds and stuff for certain things. But I'll try to figure it out. Like I said, you could do it with a bootstrap, but the bootstrap is a pain in the ass because of the way it works with caps to turn the FETs on. It's not something I want to even try to build. I think inverters use that. I'm not 100% sure though, I don't remember. But they pulse the frequencies on. It's pulsed all the time, quickly. It never changes. I usually start with this side here. usually, but this is the side I'm going to start on the left here. Get that one going, because it has the output for the motor on it, which is this one here. So I'm going to solder these into place. Just want to hold them in place here. Do the final soldering when I put the wires on. So they don't fall out. I don't know what this music is. It's just playing or playlist. It's not a playlist. It's just random royalty-free stuff. It's better than having silence in the background, I guess. Choose one of these to put in here. It don't matter. I can add a few of these pieces on here first. Transistor. I just like to spread these apart so you got more room when you're soldering on the board. You kind of want to hold it by the chip so you don't bend anything on inside there, especially with the Hall effects. Oops. Those things are really sensitive to being bent. You don't want to bend them at all. I always try not to solder in the hole, or like for transistors and FETs, because when you want to remove these, if you ever blow one, it's easier just to cut them off and then desolder it. You can put the new one in a lot easier. I do blow these up once in a while. Not very often though. If you get like on your circuit, if you ever build one of these and it's not acting properly, it's probably the transistor that's not. It might not be blown, but it's damaged. So now these are the shotkeys going in. Just gonna get everything placed in here as much as I can before I join the board with the timing circuit. Do as much work on this part of it as I can before I do that. These are pretty tough shotkeys. These are 20 amps. So I'm just going to solder them right in the hole. I don't think these ones, I've never had any of these ever blow in this 200 volt shotkeys. Same thing, I kind of spread them apart. And like when you look at a Schottky, this is how they look. And if you don't know, there's two diodes. Well, not all Schottkys are like this. This package is like this. There's two diodes that face the center, and also the back. There's also this pole here is the back too. It's like having two 20 amp diodes. The FET. What I do is I just put it like this and then spread these out too. See, I won't even solder that yet. 33K resistor. This resistor is really important. If you didn't have it, the circuit won't work. This is the one that brings your FET back to ground. Same thing here. I don't put too much solder on anything. Some of these, like this one here, will help because this is the gate here. So, and that one goes to this leg right here. So, there's quite a bit of it there already. the other resistors hooking up to this transistor. I'm going to wait to put those in when the board's connected, when I'm putting in the Hall effect. When I'm getting the, because the out of power sources are, can't remember how they are on this one. Pretty sure they're separate here. Yeah, the inputs for the circuits are separate. So you have your main power from each side coming from each separate battery. So all that has to be kept separate. Now we can connect these together. It's another tedious part of doing it. So it's nice to just keep some little pieces of these that I cut off. They come in handy for this stuff. I like to get some of these boards drawn up. Be nice, you can just stick the components on and solder them into place. Sure be nice if there was a such thing as no rope. Some if YouTube would allow everybody's music. That'll be good enough for now. I can strengthen that up and do some more. So the inputs here are going to be separate, so can't remember, I think I used the power on that one for the bottom here, and this one here for this one. Pretty sure, just check, because it worked out good on this one. Yeah. Just going to copy this one because it worked out really nice. As you can see here, the power from the input here goes to this timing circuit, and then from there it goes to the Schottky, and then from the Schottky it goes to the motor, this side of it, and then the other side does the opposite. That side, there's two positive from this side, goes to this side of it through the Schottky. So I'm just going to copy this one. Components should be laid out in the same area, because it's actually not too bad here the way it worked out for me. It's not the prettiest, but it works. I'm just going to mark these color. Bit easier to see. Some really nice wire for this stuff. Fits perfect in the holes. Tin covered copper. Solder it on yet. Now I'm going to put the power to the circuit, to the timing circuit, positive. I'm going to put that one there to there for this circuit. Yeah, and then the flyback's easy. You just hook it. You don't have to come back to here later on and just take the, because this will go back from here. This is going to go to the negative of your output on this one. This board will be over here, upside down. So it'll go from here to here. Sorry about that, guys. I didn't notice I tapped the camera. I just fell over. Oops. Oh, I've been just... I don't know when it fell over. I have to look back at the footage, but just go over what I did. I've got the shotkeys in here. Transistor. FET is there. Join the boards together in this first half. Just starting to hook up the output here. Get the outputs to the FET and the motor on this half of the circuit done. So I'm just hooking up the positive here to the motor on this side. I gotta look up all the time at the camera, I guess. So I have to keep in mind that this will also be the negative for the other side of the motor, so gotta leave room for that. And don't put too much solder yet. I'm just gonna tack it on that side for now. I like leaving a little bit of gap under them too, a little bit, so that I can, if I need to get a wire under there, I can. So this is also going to go to the negative, this rear I'm soldering right now, on the output for the flyback. That's not very nice, but it'll work. Throw one of these in here. So now the negative from here goes right here. And then this one here comes over here. All these songs sound the same. the same thing, get the power to the circuit, timing circuit here for negative in there right now. Scissors for the small stuff. Should have hooked that up first. We're soldering it. I just try not to plug those regulator holes, because that's something that could be needing to be changed. So that here goes over here, and there's also this one that goes there. So I'm gonna do them both at the same time with those ones. This is the positive from the other side, goes here, and the negative from here goes here. I have to wait for this one here because I need that wire comes from that FET from the other side of the motor, from the other pole. Let's see the latest in here. Copper wire sure takes a lot of heat. It wasn't even on there properly. the positive, I can hook that up to right now. It's kind of a pain in the butt spot there, but that one hasn't been hooked in there yet, so should be able to pull this one up and sneak a wire in there. Definitely haven't perfected putting this one together yet. Once you do it a few times, you realize which parts you should do first. Like if I wouldn't have put this wire in yet, it would have been easier. Just a hair too long. Peanut butter. I want to get these in there good though. That one I'm gonna wait because I have to put the power to the other circuit. Also be another wire here going to the diodes. Or not to the diodes, to the negative diodes, but I can just tack this in here. So now this one here has to go to the other side. So I'm going to leave this one off. Yeah. Now I need to join the boards together. Actually, no. I'm not going to do that yet. I'm going to put as much on this one as I can here before I do anything else on this one. Get these two connected together and then join them all together instead of fighting with the whole thing. FET and diodes and a transistor. Here's the diodes here. FET, transistor. These are 5408s. And I got two of them parallel together on each side of the motor. And they go to the positive of the outputs. I think these are just a bigger version of the 5399s and 4007s. Not sure on that though. I know 4007s are pretty high voltage. I don't remember what these ones are. They work really good though. That's what's in that circuit right now. I've used these on some of my other drivers. Paralleling diodes and bridge rectifiers always helps a lot if you're getting heat out of it. Like if you have a wind turbine and you got a bridge rectifier that's getting hot, double it up because you'll get that power out of your wind turbine instead of wasting it in heat. Is it a second FET going in for the other side of the motor? Same thing. 33K. Different song, would they sound the same? Same thing here, the gate that has to go to this. One of these legs on here. now it's time to join the boards together. Not too bad. So each one of these, one will go here, one will go there. I like it to keep it so this input is this output. You know, just to keep things symmetrical. So from right here, this one goes to the negative. This is the positive going into this part of the motor. There's its negative for that side of it, right here. So I can actually take it from here and put it to here. I can do the same too. I can take this one here, goes here, right? So this one can go to the negative here. Because you're positive on your input side, like say for this side, turns, it flips out, the poles flip through the diodes, right? Your flyback is opposite of what goes in. Confusing, but not really. Get this stuff here done, and then I think I'll do the last part with the Hall effects will be a separate third part. See how much time I got left here, if any. I'm done wiring these up here. Trying to go decently quick, but I also don't want to put any wires where not supposed to be. I can actually wire this one down there. I don't need to have another wire there. I can take it from here. Pretty sure that's what I did on the last one. Right. Yeah, I took it from here and I put it right to the negative. And it goes there. Yeah. It's actually a simple circuit to make, especially if you like, you understand how it works. This is just in my head. I haven't drawn it out. Hardly ever draw out my circuits. Once in a while I'll do like in every circuit, but it's hard to do that on computer. The computer doesn't like this type of work. It just doesn't agree with how it works, I guess. I don't know. It does work though, like it's kind of the same concept of a boost converter. Like even a lot of guys when they're fixing computers and stuff, they don't even understand that they're looking at a boost converter circuit. Like some laptop guys, they'll struggle when it comes to things like that to try to figure out how the circuit, like they figure that they're supposed to have a dedicated, like a lot of times there's a 12 volt source, like an inductor, that'll feed part of the board, right? But like for a laptop, you'll have usually it's 19 or 20 volts rail that feeds everything, and then you get a 3.3 volt rail and a 5 volt rail, but there's no 12 volt rail, and they don't understand where the 12 volts comes from. I seen a guy struggling to figure out where the hell the 12 volts gets made, and he was looking right at the boost converter circuit like it wasn't working right, and he was trying to figure it out. An inductor and a diode and a pulse width modulator from the 5 volt rail. And so now I could just take this one right from here and put it here. Or did I do it on this one? Yep, that's what I did. That's right here, this wire, here to there. I guess, like that guy, I don't think he was trained. Didn't have his electronics engineering, so I think that's probably where it comes in handy. To be able to identify stuff like that. If you're just a technician trying to fix something, you don't know what a boost converter looks like, it makes it a lot harder. I think I imagine it would be. Not too many boards I can't fix. It's the ones that have traces that are damaged or burnt out. Those ones are hard. I don't mind doing it, but when you're doing it for somebody, it's not that fun. Doing it for yourself, it's different. You're just buying them and fixing them, selling them again. I have a few boards that might sell. They're all fixed up and ready to go. Which one should I do next? This one. This one has to come over here. And just sneak it through here. I'll leave that one yet. I'm just gonna put this one in. Set it there like that loosely. Look at this negative here all done up. So this one here, I think I did that around here. I'll do the same. Actually, I'll solder this in here if I'm going to do it like that. Maybe I should get this one in there first, though. Negative here for the Songs are sure short too. I'll have to find some other ones, I guess. Another source of them. Don't usually play music in my videos, but ones like this that are really long and boring. It's probably, if anybody wants to build one of these circuits, this video will help them quite a bit. There's other ways to do it though. Don't have to do it the way I'm doing it. Just what I found works good for me. Imagine I put that one there to there and this one too. That's just a short wire from here to there. And this one has to go here. But I could just steal it from here. Yeah, I don't know why I did that here. That could be changed. This wire goes here. Yeah, I can completely eliminate this wire here. Just noticed that. Just put that to there. Try it anyway. See if it's not working. If there's anything. You know, it's obviously better to connect it from here to there. It's a direct connection. But it's not that much. We'll see anyway. I'll try it. I'll just go from here to here. It's easy to fix it if I need to change it. If it's not acting right. Makes it easy. This one goes here to here and one there to there. I could balance it out by doing the opposite, you know. but it'll work. Or I can take this one, put it here, and eliminate that wire, and then keep this one short if I wanted to. Next circuit I'll do it like that, because then it'll equal it out. Oops. So that's the power circuit done. these wires sticking up quite a bit here because then we got some of these resistors and stuff to go in there for the Hall effect circuit from the transistor to the gates and the FETs. But that's going to be a part 3. That's another good hour at least.